Hello everyone, welcome to Self-Dev. Have you ever questioned yourself about Graceful Shutdown? Have you ever wondered how does it works and what happens behind the scenes? Basically, it's a common behavior in many applications nowadays. Um, Even if you work with Kubernetes or any other SaaS implementation such as App Engine for Google or Cloud Run from Google Cloud or even Fargate from AWS. Usually these applications they behave the same way, right? Um, but what happens behind the scenes? How does it works? Is it very difficult to understand this process? Because basically, mainly what happens is we have a SIG term or SIG sign from operation system, and the application must do something. This usually happens for many reasons. The most common is on never deploy, or if you're having memory issues or CPU issues, and if you're using Kubernetes as an example, if the Kubernetes check understand that your application needs to be recycled or needs to be out for some reason, they're gonna go through this process. So basically today we're gonna try to implement, of course, in a very 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 uh, tiny codes, but trying to understand the behavior, which is the most important here, right? So let's code. What is the three good steps that a graceful shutdown goes through, right? Three steps. The first one, whenever we have a SIG term, we need to stop, right, all new requests. This is the first step that our every application agrees shutdown does. After that, we need to wait for all in-flight requests to be done. And after that, we need to close all connections and shut down. So this is actually the three steps that every shutdown process does. Most of the frameworks in Golang, they usually call the HTTP shutdown implementation, which already does these kind of things. But my question is, how difficult it is to trying to implement such a behavior like that, right? Because we might end up having things like that, but not with request itself. Let's say if you're implementing, I don't know, a subscriber, and whenever you receive, uh, you know, you receive a shutdown process, you need to stop consuming message, wait until all the consumers finish their jobs, their ongoing jobs, and then you close and shut down, right? So actually this happens for everything that you're doing, every job that might be doing in your application. But let's try to implement something here. So basically what we're gonna do, we're gonna create a wait group here, right? We're gonna create a sync once. We're gonna use that for a specific thing. Uh, After that, we're gonna create a buffer channel. So basically here, this it's simulating incoming simulating requests. Okay, so here we are simulating the request in this queue here, right? After that, we're gonna have a job just to control whenever it's done or not. And last but not least, we're gonna have the signals. So here we're gonna create the signals to we can here we can listen for SIGINT, right? But I will also put a SIG term just to enable us to with Control C emulate that. So I'm gonna call the syscall directly, SIGINT and SIG term, right? So let's start it out. Now we're gonna launch a Go routine. So basically we are launching a Go routine here. But after that, we're gonna add a job in our group. We're gonna call the defer here to guarantee that this is done after the process. And now we're gonna have an endless loop here, right? So we're gonna select case here. here we're gonna have the task, and here the okay. So basically, if there is if that operation is not okay, from the int, we know that the channel, it's closed, right? So if the channel in that case is closed, we're gonna print out something here, but we're gonna return. So we are gonna do um, no task will be accepted anymore. So here is the case where we are closing all the new incomes requests, right? As I said, the simulation of the request comes from the channel queue. So here it's not okay. It means that the channel has closed, so we don't receive that anymore. All right. So we stopped receiving new things. So now we are fulfilling the number one step. Now we go to number two. So after that, we're gonna emulate some heavy jobs uh, inside. So mainly this case, we are not operating anymore, but this case now here, we are operating, right? So these are the in-flight requests, okay? So these are the in-flight requests, and it took task, and we're gonna create a process time here, and this process time gonna be a time duration, right? Basically, we're gonna create a rand int um, just to just to um, have different times every time that we execute that. Okay, so every time that we execute, we can go from 3 seconds to 1 second, and we're gonna have these different, this main different every time, right? So that's it. So we might have 3 seconds or 1 second of process time. These are the in-flight requests. He's complaining about something, maybe the string, what it is about. Oh, it's printf. Sorry. All right. And now we're gonna time sleep here. So we sleep the process time, right? Now we have the case which is done, which is once it's done, to avoid concurrency in here, we're gonna do that sync once that I said. We're gonna close here the queue. So basically here is the thing. Whenever we're done, we're gonna receive done channel, and we're gonna close the queue. So we're closing all the requests, right? And this will be catched by this guy here. So this go routine, it's that we launch is done. So now we're gonna open another go routine, and this new go routine, we're gonna have for, let's say, I don't know, 20, and we're gonna have a select case here, right? Um, Basically here we are stopping sending new requests, right? And we're gonna return, and as a default here. So whenever we are not stopping, we are just putting new requests inside the queue. So here's the, it's the accepting request, right? Incoming request. So let's say that new request, queue it, and that's it. It's printf again, new request. So now we are just like time sleep here, 5 milliseconds, just to, right? So now we have this. So basically now we're gonna have a signal. We're gonna wait for the signal that we created up here. It's signals. So we are waiting for signals, right? We got signal here, and we're gonna close done. So basically now we are closing the channel, and we are now definitely shut down the application, right? Application has shut down. So basically going through again, we have the Go routine that will be able to handle all the behaviors, and the coroutine responsible for putting all the income requests. So let's say that here is the Go routine that every time that we receive a connection, it's dispatch a Go routine. That's how it does work, right? Every HTTP implementation, every request on every router creates a new Go routine. So basically behind the scenes, it's almost that what happens. So we are putting these requests in the queue. We are processing, right? This is the processing simulation. And now we will be able to handle that. So let's run that to see if it works. Go.main. So now we are receiving the request, right? Now if I do Control C, which is the interruption, we're gonna see that now we are waiting for all the in-flight requests to be done. We are not receiving any new requests. We are processing all the in-flight requests. We wait for everything, and then we shut down, right? So that's the behavior. We receive a new request, we queue it, we have an in-flight, we receive 3 requests, we have 1 in-flight, we receive 4 new requests, we have 1 in-flight, we receive 3 new requests, we have 1 in-flight. Once we interrupted by OS system, operation system, we stopping sending new requests. So we are not sending anything else, right? And now we wait for all the in-flight requests to be finished. Because now we didn't process the 1 and the 2, but 3, 4, 5, 6, 7, 8, 9, 10 wasn't finished yet. They were in flight. So we wait for everything. No task will be accepted anymore. The application is down. So basically, that's what happened whenever shutdown process happens in your Golang application, your Node application, but here we are mainly using Golang. Hopefully you enjoy that video, and if you like that one, please subscribe, and you know we'll try to do our best to put out new videos with this kind of content that we believe it's very interesting. So hope to see you next time, and bye bye.